let me go to the next topic. So I want to believe that I've resumed the recording. So the linear programming in logistics, I just want you to have an idea of the maximization. I want you to have an idea of the maximization. And what this does is that it tells us about, the linear programming is all about profit maximization, or it will tell us minimizing the cost of running the entire system in the logistics organization. Especially, it is more applicable to the inbound logistics that has more activities with the supply chain network. That is where the linear programming works in logistics system. Now, I want us to understand how the profit maximization, we want to see the point at which we make the highest profit. And the key components for you to understand this are the objective function, then decision variables, constraints, and so on. But I am more interested in this particular exercise, for example. Now, let's assume that this particular person here is a logistics person who have developed two plans, plan A and B. And the plan A requires 2 hours of the academics time and an hour of the private time, with plan B requiring an hour. Both from them, the academics has 100 hours and the other has 80 hours of available time. Profit for plan A and B are 1,000 and 2,000 respectively. How can the logistician, for example, get maximum best return? So what this suggests is that we want to see the point at which there is profit maximization. And if you look at this table, you will see that what you just need here is, this is working with X, and this column is working with Y. If you look at this column, can you confirm that on your screen? This is the column X, and this is the column Y. And if you see this exercise, it is being depicted with what we have here. These are their corresponding profits. These are the two different plans. So now this is suggesting that if we have one, we should just put the alphabet. We should just put it. And if we have, that is, as we have 2x plus 1y, you don't put it as 1y. You write it here as 2x plus y. This is the entire x. Why this is the entire y? Class, could you confirm you are following to these points?
Okay, so if it's one, you just make it as y. But what if you have 2 or 3? Will you not put 2y?
Yes, you will now put 2y, or you put 2x. But if it is 1, you just put only the alphabet. That is why this place in the subject, you know, what this is now saying is that we should maximize P. This is how it is written as a question, that maximize P equals 1,000x plus 2,000y. This is extracted from here. This is where, this maximization is where we are coming to at the end of the day. We want to maximize profits, but we want to write the linear equation. This is how we write it, that it is subject to P maximize 1,000x plus 2,000y. So subject to this 2x. This 2x is extracted from here. So if this place is 7, it will be 2x plus what? Class. If this one is 7, this place will be 2x plus what?
7.
Now, which one is 7,
7y.
sir?
7y.
If
Is it
7,
y or x?
7y, 7y.
It will be 7y. See, this place is our x. Can you see the cursor on your screen?
Sir, your
Sir,
cursor
the
is not
cursor is
moving.
not moving.
I don't know if it's from my head
It's
alone,
not
but the cursor is
moving.
not moving.
Okay, what of it? Is it moving like this?
It's moving now.
Yes, it's moving.
Yes, it's moving
Okay.
now.
Okay, this is our X. This is our X column. Is that okay?
It's not okay. Oh. We are not seeing what you are doing.
Sir,
Can you
are you
see
taking
this?
Is it the academic?
academics? The academics.
Yes,
Yes,
is our
academics
X.
is X,
Yes.
while
It's
private
X.
firm Y.
It could come in form of logistics or supply chain. I'm just using academics as an example. This place now
Copy.
is our. Can you see this? Can you see the cursor again?
Yes, we can see.
Everything
Oh, I
here.
can see.
This place here, with these two rows, this column is on X. This is on Y. Okay, and that is why this place is 2x plus y less than or equals to 100. This is the 100. Yes. So this one, this place, this is this place is X. Sorry, class. This is our X. This is our Y. The whole of this place has the X and Y. Everything here is for X and Y, not here and here. Okay? Because if you look at this place on the maximization, you will see that our X is 1,000, our Y is 2,000 on this place. Can you confirm that?
Yes.
Can you confirm that? So the whole thing starts from
Yes.
here. Understanding it starts from here. So this is our X, this is our Y. And that's why we have maximize P equals 1,000 X plus 2,000 Y. So forget about the initial information of X and Y. Let them face their information individually. So this subject to X, 2X plus Y greater than or equals to 100 is the whole thing here. Do you get it to this point?
Yes.
So that
sir,
means if this one
hello,
here,
sir, is the
yes,
Y.
I'm listening.
So I just want to ask
The
that
whole
is
of
the A that
one
is
is the Y.
X and the B is Y.
Yes. Thank you. You are correct. Yes. That's it. So if we have 8 here, what do you suggest? It will be 2x plus what?
8y.
8y less than or equals to 100.
100.
Where is
100.
it? Is this 100,
Available
right?
time.
It is this 100.
Okay.
So do you understand it to this point?
Yes.
Yes.
So write the same thing here because this is 1 and this is 1 and this is 80. That's why you have it here. Okay? As
Okay.
x
Okay. Yes.
as x plus y plus 80. If it is 5 and
Y.
10, if it is 5 and 10 that you have here, what we have here is 5x plus
5x plus
10y.
Plus 10y.
10y.
less than
Less than or
80.
equal
less than
to
equals to 80. Okay, so we are writing our linear equation now. So now what you now do is our x is greater than or equals to 0, comma y greater than or equals to 0. So this one is just to draw a straight line at the end of the day when we are plotting. Now, the second thing, what we have done here is to formulate the problem into a linear programming model. That's what you have here direct. That's what we have done here. Number 2 is to consider each inequality constraint as equation. So all these greater than or equals to, you can see that we are saying equals to here. Can you see that?
Yes, sir.
So that is number 2. And you have to read through this and you see that we just have to convert it into equation. So if you see this particular one now, we are now going to the third level is to plot the points, to find the points to plot the graph. We want to plot it on the graph now. Now for equation 1, when x is 0, y is equals to 100. Let me go back to it. Look at this. When x is 0, Do you agree with me that y equals 100? Because when x is 0, 2 times 0 is what?
0.
0.
2 times 0. So y equals 0. Is that correct?
Yes, it's called 100.
Sorry, y equals 100. Thank you. When x is 0, y equals 100. Now, let's do the other way around. When y equals 0. Where is it? When
S
this
is
y
equal to
equals 0, s equals what? 100 over 2, right?
100.
Is it 100
Yeah,
over
that's
2?
50.
That's
That's
equal 50.
50.
we have this 50. We are on
Okay.
equation 1. You know, we converted it to equation. This is the point
Okay.
of equation conversion. This number 2. It is self-explanatory. Can you see the number 2? Am I touching it?
Yes, sir.
So we have converted it to 0. And we are on this first equation. So on first equation, you solve for x and you solve for y. When we solve for x, when x is 0, y equals 100, right? We solve for
Yes.
y. When we're solving for x now, when we solve for x, okay, that means y equals 0. That's why we have 0 here. Can you see the 0 here? Y equals 0.
Okay, sir.
On that same equation. On the same equation, on equation 1, you put x as 0 and you put y as 0. When x is 0, y equals 100. Now, when y equals 0, x equals 100 divided by 2, which is 50. Am I correct, class? Are we on the same page?
Yes.
Yes.
So therefore, the points are 50 and 100. Why are we writing 50 before 100? Because we are moving with x and y. Is that taken?
Yes, sir.
Yes, sir.
So the same thing is applicable here. Look at this. For equation 2, can we do that together again? Equation 2, which is this one, x plus y equals 80. That means when x equals 0, y is 80. Is that correct?
Yes, sir.
Yes.
When
And otherwise,
y equals 0, s equals 80. Is that correct?
Yes, sir.
Therefore, the points are 80 and 80. Then what we need to do here is to now number, that is, number 3 is to find the point on the graph.
On the graph.
To plot the graph, the point to plot the graph. We have value for the first and second, 50 and 100 and 80 and 80. So we want to plot the point on the graph now. Now, what we do to points, we have gotten the points. We have found the point on the graph. So for us to plot the point on the graph here, okay, look at the graph. I don't know. Let me see if I can increase it. Is it bigger now?
Yes, sir.
It's calculation.
Okay. Okay. I believe it is bigger enough like this.
Yes, sir.
What we do is that this shading, shade it down, because we are doing maximization. We are shading it down. If it is minimization, you shade it up. Now, if you look at these points, let me take it up again so that I can see the 50 and 80. Can you see the 50 here?
Okay, sir.
The first point, what are the figures? For the first points, what are the figures? When x is what? For the first one, we have 50 and what?
100.
100.
100.
We have 50 and 100. This is 50. This is
That is
100. The second one, 80 and what?
80.
Am I
80.
touching the first? Am I touching the first 80?
80.
Am I touching the first 80?
No.
Yes.
This is
Yes,
one
you
80
are.
here, and this is another 80. So you now draw the lines to meet the, for the first line, this 100, Don't forget that this is
Two.
y-axis. Are you seeing the y-axis on your screen?
Yes.
So on the y-axis, we put the 100, and on the y-axis, the 100 to 50, 50 to 100, you draw the line. Then the 80 to 80, you draw the line. Then you now pick the points that are inside. That is the, we call it feasible region. That's what you have here. We call it feasible region. You now rename those points. These points A, you know they are inside. These are the inside. You can see my cursor. They are inside. You are not having business with all this. So that's why they are inside. You get the ones that are inside, then you shade it. Can you see the shading? Can you see the hashing?
Yes.
So you now pick the point. This point A. Are you seeing the point A?
Yes. Yes, sir.
Are you seeing the points? This point B. Are you seeing the point B?
Yes, sir.
And this is point C. That's why we have point A, B, C. This D is it can be D, it can be 0. This place. It can be D, it can be 0. Some textbooks will tell you it is 0. So now, what you will now need to do for this region is that after you have found that region, you now do the optimal solution. You know, I said this particular P equals, let me show you. During the formulation of the linear problem, can you see this on my screen? Maximize P equals 1000x plus 2000y. If I want to give you question, don't bother yourself. Don't bother yourself. I will give you, class rep, are you on the same page? I will give you the question, I'll give you the story, and I'll give you the table so that you can just extract direct, so that it will be easier for you. I will not give you question and argue and say you should create the table, so that I can just extract direct. Okay? So this is where we are coming back to for us to calculate. This is where we are coming back to for us to calculate the highest profits. Are you following?
Yes.
Yes. Yes, sir.
So quickly write this down. Write maximize P equals 1000x plus 2000y. Quickly write it down. Then we now apply it here. Have you written this? Have you written this? Class.
Yes, sir.
Oh yeah, let's quickly go to the application points. Let's go to the application points. Can you see this? Number 6 instruction is the optimal solution. The optimal solution is at what point are we getting the maximum best return? So now look at this. If you have written that, you see that it is the same thing that is here. Am I correct? P equals 1000x plus 2000y. Can you see that it is the same thing?
Welcome back. Oh, fine.
Class, are you following these points?
Anyway,
Mute yourself. If you are not in the class, mute yourself. If you are in the class, just follow me this same way. So when you put this, I told you, class governor, remind me, when I'm giving you a question, I'll give you the story of the logistics, and I will also give you the table so that you can just extract directly. So if you look at this that we have extracted from the formulation of the linear problem that we had here, this place, in the formulation of the problem, that is what led us to these points where we are. So that's why we are writing P equals 1000x plus this. So look at the feasible points. Point A, now this is point A. X is 0. This is our 0. Can you see the 0? Class,
Oh,
can you see
this,
the 0?
Yes, sir. Yes, sir.
This is our Y. Look at it here. Point A, on the feasible solution, we now have business with the feasible solution at each point. So for the feasible solution for point A, look at the point A that we highlighted. You know, I told you that I should forget other points. that we have gotten all the internal points that are giving us our feasible region.
Optimization.
The point on the feasible region, that's the feasible solution for the linear programming. So this A that you have here is what you have here now. That is 0 and 80. 0 and 80. Then this B that you have here, if you look at the graph, okay, if you look at the graph down, I see it that it is 0.20 on
20.
X. I see 20.
And on
Can you see 20 on
yes.
X? That's the
Yes,
20.
yes, yes.
Then
Yes.
on this B, you now
Yes.
look at your y-axis again. Can you see 60? This is
Yes.
the 60 here. This is the 60. Point C. These are point C. What figure are we seeing on point C? Can we see 50?
50.
Yes.
Yes.
On X. You know, we say X before Y. Then can you see 0 again on the Y?
Yes.
Yes.
On
So then our D is 0 and 0. Our D is just 0 and 0. So now, because our D is this place, so it's both 0 and 0. You know, I told you our D can be point 0 and it can be point D. Don't forget. So we just want to find the optimal solution now. So what do we need to do? We write the formulation out where we maximize at the beginning. P stands for profit, maximization. 1000x plus 2000y. So at point A, what you need to do is to bring these figures and put inside.
Okay.
When you bring the figure and put inside, this is our x, this is our y. Point A, this is our x, this is our y. Our x is 0, this is the 0 to multiply the 1000 plus this is
0.
the 2000,
2000
our y, this 80. This 80.
times
Is that clear?
2.
Okay. Yes.
So we go to point B again now. On feasible region, look at our point B. We have x 20, y 60. So the same thing, x 20, y 60. You multiply and add, then you have 140,000 here. At this point, you do the same thing. You have our 50 at x, we have y at 0. 50 first, 0 y later. Then the same thing happens here. So at point D, we have 0 naira. At point C, we have 50,000 naira. At point B, how much do we have?
140,000 naira.
Then at point A, how much do we have?
160,000.
So we can conclude that the logistician will get maximum best return at what point?
Point A.
On D.
Point A.
Point A.
Exactly.
Point A is maximum.
Yes, it's point
A.
Point A, not D. Don't follow the slide. Just follow the solution. That's where you get the maximum. That is a typo. Don't follow this one. That's where you get the maximum. At times it could be at point C. At times it could be at point D. That's just all you need to do on linear programming. Do you have questions? Just follow this
then
number.
now what happened to this therefore the town planner will get maximum
No, I
profit.
said the logistician. It's just a sample. Yes. Maximum best return at this place. That's for profit maximization. It is for profit maximization. It is at this point. This is not significant.
Yes, sir.
I hope that is clear enough. Do you have any question on this linear programming? It is straightforward.
How you got the
question is-
feasible region is not clear.
Okay, very good.
Yeah.
Let me go back to how I got the feasible region. Now, you know, we solved for, let me go back and follow the same. Now, what we did was to follow the equation. Look at this first equation. The first equation 1 is what? 2x plus y, right?
Yes, I got how you plotted the graph. In the graph, how to know the feasible region. That is what I want to
Okay,
get.
thank you. Very good. Look at those lines that are internal. Look at this line now. Can you see my cursor?
Recording.
Or only the
Yes.
internal, the last down lines. Those are the lines that you will shade. You will shade them for you to get them. You hash them or shade them. You can see that. You can see that these lines, you can see that I didn't touch this place because there is a line under it. You can see that I didn't touch this place because there is a line under it. It's only the last line before the X and Y axis that you will shade or hash. So that becomes your feasible region. That's where the solution lies.
Okay, so how do I get my point? Point
You
A,
can see the
B,
correction.
C.
You can see the correction I mentioned in this place that it is 160,000. You can see that it is not D. Can you see the clarification?
Yes, I understand this aspect. It's just that.
It is not D. It is just a typo from the source. I just need to make you understand it faster. I don't want to waste time doing a special one for logistics. It's the same thing. What I'll just do is I'll use logistics terms or supply chain terms instead of this place for you. And this place is A, and the justification is the 160,000, which is here. So that's when you get the best return, and you can use it for your decision making.